slow and help you with these problems. Okay, number 43 is the first one on page 22. You have two summer jobs. Okay, so we're going to put job number one right here, job number two over here. It's very helpful when you're solving word problems to sometimes list out the information so that you can see it broken down into different categories or whatever the situation might be. So here we go. In the first job, you work 40 hours a week. And you earn $6.25 an hour. The second one, you earn $5.50 an hour. And you can work as many hours as you want. So hours unlimited. Alright? Hours unlimited. Now here's how much money you want to earn per week. So everything's per week here, okay? You would like to earn, here's your goal, $316 a week, okay? Now, how many hours must you work at your second job? Now I'd like to make a comment here, throw a thought out at you. This problem is impossible to solve if you don't know how much money you need to make on your second job. Do you see what I'm saying? Look, you know that you get $5.50 an hour, but I don't know if you want $100, $200, $300. I mean, look, if I know that you want $11, no, I know you want more than that, but if I know you want to make $11 from this job and you're getting paid $5.50 an hour, then how many hours would you have to work? 2, because 1 hour you get $5.50, the next hour you get $5.50, that's $11. So I can definitely find out how many hours, and that's the question right here. How many hours must you work at your second job? I can answer that if you will just tell me how much money you want to make over here, okay? And that's the problem. I don't know how much money I want to make. So that's what we really have to take care of first. That makes sense? Okay, now remember, if you would not have thought of what I said, that's okay. I'm not asking you to think of this on your own. I'm just saying, what I'm saying making sense? That's the question you want to ask yourselves. That should make sense. Now, actually, I can find out how much money I need to earn over here by first coming over here and doing this. I know I make $6.25 an hour, so every hour I make $6.25, and I'm going to do that for 40 hours. So if I take $6.25 times 40, I get $250. So I already know I'm making how much from this job here, $250. How much do I want to make total from both jobs? $316. So I know I'm making $250 over here. Subtract that out, and you're left with $66. Okay. So now I know at this job here I have to make $66. So this is pretty easy, guys. Look, if you take, remember, you're making $5.50 per what? Hour. So if I take $5.50 times all of my what? Hours that I work, I want to get how much money? Does that make sense? I'm making $5.50 an hour. So if I take $5.50 times all of my hours, HR, that'll give me 66. So to solve for HR, these two are multiplying. We're just going to simply divide both sides by 550. And if you do that, trust me, you will get 12 for your hours. 12 hours. Now if you want to check that, you're making $5.50 an hour. So take $5.50 times 12 hours and you will get $66. Okay. Alright, not too difficult. Let's continue on. Okay, let's take a look now at number 44. I know it says 4 right there, but it's number 44. I think it's 44. Yes, 44. Alright, here we go. The bill for the repair of your car was $415. Okay, so there we go. Total bill. $415. The cost for parts was $265. So the parts they had to order for my car, the total cost for the parts was $265. Now the labor was $25 per hour, okay? Labor is $25 per hour. Now you know what that means. That means if they work 1 hour, you pay $25 on top of this. If they work 3 hours, you pay, well, 25, 25, 25, $75 on top of this. If they work 10 hours, you pay 250 on top of this, okay? So, here we go. How many hours did the repair ticket take? So in other words, how many hours did the man work, or woman, sorry, whatever, work on your car? Now here we go. First of all, the parts was 265. Your total bill is 415. So I'm going to subtract out the parts because the parts have nothing to do with your labor. Nothing. That's how much money they paid a place to buy your parts. So your total bill is 415. Let's subtract out the parts. If you do that, you're left with $150. So now I know how much labor you had, 150. So think about it. If I take $25, right, that's how much it costs for every hour. $25 times every hour that he worked, I'm going to get how much money for the labor? Well, I'm not going to get it. I'm going to pay. I'm going to pay how much money? $150. So how many hours did I work? Now, a lot of you can do that in your head. You don't even need this equation. You know right away the answer is 6, and that's fine. But others need a little help here. So $25 times each hour gives you $150. That's how much money I had to pay. So these two are multiplying, so I'm going to divide both sides by 25. And H equals 6. Now if you want to check your work, go back up here and check it. You're paying $25 an hour for 6 hours. 25 times 6 is $150, okay? And then your parts, here's your labor right here. Your parts was this much. Add these two together and you will get $415, okay? Alright, number 45. Now you're going to have to look in your book. I probably should have taken a picture of the information in your book, but I did not, so that's my fault. Let me turn back in my book here. Above number 45, actually, I don't know if you really need that information or not. Above the two, on page 22, you're going to see a picture of two tractors, excuse me. And above those two tractors, you will see some information. I don't think you need that. Let's see if you do. Here we go. The 1991 tractor has a horsepower of 195. So I'll put 1991. I'm going to put HP for horsepower. Horsepower of 1,009 or 195. Okay. Now over here at the 1917 tractor, I have a lot of information about. Okay. But here's what we do know. Now remember, let's talk about some keywords. In algebra was, those types of words usually mean equals. Of is usually going to mean multiply, okay? Don't forget that. So, here we go. Watch carefully. The 1991 tractor has a horsepower of 195. That is 5 less than 4 times the horsepower of the 1917 tractor. What was the horsepower of the 1917 tractor? Now, a lot of you are not going to need an equation. That's fine. Those that do not feel stupid. That's fine, okay? A lot of you read this right away and you say, oh, it's easy. This newer tractor has almost 4 times the horsepower of this. It's 5 less. So I'm going to take the horsepower of this tractor. I'm going to add 5 to it. That gives me 200. And then divide it by 4 and I'll get 50. A lot of you can see that. Well, I don't know about a lot of you. Some of you can see that, and that's fine. But a lot of you, or most of you, probably need an equation to help you solve this. So here's what I recommend. Watch this carefully, please. The 1991 tractor has a horsepower of 195, okay? Which is what is 195 is. Look, the 1991 tractor has a horsepower of 195, and this horsepower is 5 less than 4 times. So here's what I'm going to put. I'm going to put the 1991 tractor horsepower. So 1991 tractor horsepower. Got it? 1991 tractor horsepower is, that means equals, is what? 5 less than 4 times. So I've got to take 5 less. I'm going to subtract 5. That's what it says here, guys. Look, 5 less. Now, a lot of you see 5 less, you put negative 5. Hold on a second. That can work, but it's a lot easier if you look at it like this. It's 5 less. If I said your wallet is 5 less dollars, you would take the money in your wallet, like 20 bucks, and subtract 5 from it, okay? So when it says 5 less, that means 5 less than something. 5 less than what? 5 less than 4 times the horsepower. So here it is. 5 less than 4 times what? The horsepower of the what? 1917 tractor. Let's go through it again very slowly. The 1991 tractor has a horsepower of 195. Okay, so the 1991 tractor's horsepower is 1991 tractor horsepower is equals 5 less than 4 times. So 5 less than 4 times. 4 times what? The horsepower of the 1917 tractor. That's what you're looking for. What's the horsepower of the 1917 tractor? So this is what you're looking for right here. You're looking for the horsepower of the 1917 tractor. Now, I'm going to go ahead and let X represent the what? Horsepower of the 1917 tractor. So instead of having this big gobbledygook here, I'm just going to put X there. So now I have 4x, 4 times x minus 5. Now what goes over here? We'll read it. 1991 tractor horsepower. What is the 1991 tractor horsepower? 195. Booyah. There we go. Now let's solve for x. So we're going to bring the 5 over and make it a positive 5. That would give us 200. Now divide both sides by 4 and that gives you 50. There you go. So what does x equal? X is the horsepower of the 1917 tractor, and that's 50. So 50 is the horsepower of the 1917 tractor. Let's try another one like this, okay? Here we go. The maximum speed of the 1991 tractor is 19.6 miles per hour, okay? So the 1991 tractor has a speed of 19.6 miles per hour, which is 1.2 more than 8 times the maximum speed of the 1917 tractor. What are we looking for? We're looking for the maximum speed of the 1917 tractor, okay? So here I go again. I'm going to try to pull an algebra sentence out of here. The maximum speed of the 1991 tractor is this, which is, so the maximum speed of the 1991 tractor is speed of the 1991 tractor. Speed of the 1991 tractor is equals 1.2 more. So I'm adding 1.2 to something. 1.2 more than what? 8 times the speed of the 17 tractor. So 8 times the speed of the 1917 tractor. Okay? Got it? Let's go over it again. The speed of the 1991 tractor is, so speed of 1991 tractor is equals 1.2 more than 8 times. So 1.2 more plus 1.2 more than what? 8 times the speed of the 1917 tractor. Now I'm going to allow X to stand for the speed of the 1917 tractor. So instead of putting all this gobbledygook here, I'm going to put 8 times X plus 1.2. Now, what is the speed of the 1991 tractor? Right here, 19.6. And now let's solve this thing. Subtract, bring the 1.2 over, make it a negative 1.2, and you're left with 18.4. Now divide both sides by 8, and you will get 2.3 equals x. So the answer is 2.3 miles per hour. There we go. That's the speed of the 1917 tractor, the maximum speed. Okay, let's try another one like this, number 47. 1917 tractor. They made a total of 65. Okay. Now, the Case Company made 65 tractors, which is, or in other words, this is, so the number of 1917 tractors is, the Case Company made 65 tractors, which is, so the number of 1917 tractors is 35 less than, so we're going to subtract 35 from something. 1/100th of, so 1/100th of, that means multiply the tractors in 1991. So I'm gonna put tractors in 1991. Let's go ahead again. Look, is equals 35 less than. So 35 less than what? 1/100th. So 1/100th of times the number of tractors made in 1991. Now, the tractors made in 1991, I'm going to use X to stand for that, okay? So I'm going to put an X right here. So here we go. The number of 1917 tractors is 65. 1/100th times X is 1/100th X minus 35. Now you could, I'm going to go ahead and eliminate fractions. Step 1, simplify both sides. Nothing we can simplify. Step 2, multiply everything by 100 to get rid of your fraction because your denominator is 100. So I'm going to multiply everything here by 100. 100 times 65 is 6,500. 100 over 1 times 1 over 100. Your 100s would cancel, leaving you with 1x or just x. 100 times 35 is 3,500. And now just simply bring the 3,500 over and make it positive. And you will get the answer, which is 10,000. So 10,000 what? Well, they made 10,000 tractors in 1991. There we go. Okay. Of this type right here, the Magnum 7140 tractors, they made 10,000 of those in 1991. Okay, so these aren't too difficult if you learn to kind of read the words and figure them out that way. All right. Okay, moving on to the next page, which I believe is page 28. All right. Now again, don't say to yourself, don't freak out and say, I would have never thought to have done that. No. Say to yourself, do I understand what Mr. Earhart's doing? And if you understand, you're fine. Okay. Look, the more you practice these, the better you'll get at them. Okay, it's okay to be a little confused. The question you're asking is, not what have I thought to have done that, but do I understand what he's doing? If you understand what I'm doing, you'll eventually start getting these. Okay, now on page 28, number 13, the question simply says, what wind speed will allow the balloons to reach the Atlantic Ocean? Okay, now, everyone relax, take deep breaths, let's look at your book, okay? First of all, it says you are attending a wedding in Cedar City, Utah, okay? So if you'll look in your book, I should have taken a picture of this, I did not. That's my fault, okay? I did not want that. So here is a picture of the United States. That's an amazing picture of the United States. I think you have to agree with me that you've never seen a better drawn picture of the United States. Now right here, if you look in your book, you'll see Cedar Grove or Cedar City, Utah, okay? Now, notice it has a blue circle. See this blue circle right here? Right here. And it says, if you'll look to the left of the picture in your book, it says the radius of the blue circle is 1,000 miles. So when you see this blue circle right here I'm drawing, when it says radius, just in your mind, watch this. When I do this, it's going to make it so much easy for you. Just continue the entire circle, and then you'll see the radius is 1,000. Got it? Okay. Now, the green circle, if you look in your book, is about right here. Okay? Now again, I don't want any of you becoming discouraged that you do not have the artistic or drawing skills that I have, okay? It's taken me years to acquire this level of drawing skills, alright? Alright, there we go. Now, 2,000 miles. Now a lot of students go, oh, okay, so from here to here's 2,000 miles. Hold the wagon for a second, guys. That's not a radius. A radius has to start in the center of the circle and go to the outside. So from here to here's 1,000, but from here to here is 2,000. Okay, so if from here to here is 1,000, and from here to here's 2,000, then I know this little bit right here has to be how much? 1,000, because from here to here's 1,000, but from here to here's 2,000, so this little bit has to be 1,000. Okay, I hope that helps a little bit. Now, I didn't draw my picture well at all, did I? Oh my goodness, I messed that up. The green circle, that's really not good. I need to fix this. The green circle is supposed to go all the way out to the edge of the United States. Or if you look in your book, you'll see it goes all the way to the East Coast here. So what we're going to have to do here is help my picture by shrinking the United States of America. Okay, what a catastrophic incident just happened. We have shrunk America. All right, now, so this is right on the eastern sea right here. Okay, now the sea, the coast, right on the eastern coast. Now, what wind speed will allow the balloons to reach the Atlantic Ocean? Well, if you'll look, in the information to the left of the green picture, it says, the very last sentence says, after 24 hours, the balloons fall to the earth, okay? So, the balloons are in the air for 24 hours. Got it? They travel from, we want the balloons to travel from here to here. So we want the balloons to travel how far? Isn't that easy? That's not hard. 2,000 miles. In how much time? 24 hours. So, can we figure the miles per hour? Oh my goodness, yes. Guys, you have to remember this from middle school. Probably elementary school. Rate times time equals distance. In other words, if you're going, let's say you're going to play a school, a school in there, and you're traveling 60 miles an hour on the bus, and you do that for 3 hours, then how many miles did you travel? 180, because you're traveling 60 miles per hour every hour. You do that for 3 hours, that's 180 miles. See how this works? Rate is your speed, time is your time, distance is your distance. Okay, so rate times time equals distance. So with that in mind, look at this. What is my rate? I don't know. Look, that's what they're asking for. What is the wind speed? The wind is pushing these balloons toward the west or toward the east coast. What is the speed? That's what I'm looking for. So I'm going to leave this R. The time I have is how much time? 24 hours. The distance I have is 2,000 miles. Now, R times 24 is the same thing as 24 times R. So 24R equals 2,000. Divide both sides by 24. And your speed would be 2,000 divided by 24. 83.3 repeating, which is a fine answer, or you can use a fraction. 83 and 1/3. How do I know it's miles per hour? Because your time was in what? Hours. And your distance was in what? Miles. So that's miles per hour. Now let's take this a step further, okay? Let's take this problem here, and let's see if I can get rid of this here, and this here, and this here, because I don't want to waste. This drawing is really, as you can tell, it took me hours to make this, and I want to keep this drawing for the next problem. So, here we go. Now the next problem, and I'm sorry about this JPEG file thing here, I'm not sure why it came up on my computer, but anyways, suppose the balloons, you can read this in your book if you need to, suppose the balloons remain in the hour for 36 hours. What would the wind speed need to be to allow them to reach the Atlantic Ocean? Well, first of all, let's go back. A wind speed of 83 miles an hour. That's, what is that, hurricane level maybe, I'm not sure, but that's pretty unusual. Well, what if the balloon stayed in the air for 36 hours? Now, what would the wind speed need to be? Well, guys, once again, has the distance changed? No. Even though I shrunk America, the distance has not changed. It's still 2,000 miles from here to here. So I've got the exact same formula. We're still looking for speed. What would the wind speed be? So I'm still looking for the rate, the speed. The time is now what? They're going to stay in the air for 36 hours. The distance is 2,000 miles. R times 36 is the same thing as 36 times R. Divide both sides by 36. 2,000 divided by 36 would give you 55.59 or 55.5 repeating. Okay, that's fine, or this is fine. Miles per hour. So you throw the balloons up after the couple is married in Cedar Point or Cedar City, Utah. You throw the balloons up, they take off in the wind, they travel 2,000 miles in 36 hours. What was the speed of the wind? 55 miles an hour. Okay, not too difficult. Okay, number 15, you are taking hang gliding lessons. The cost of the first lesson is 1.5 times the cost of each additional lesson. You are spending $260 for 6 lessons. How much did each lesson cost? Now again, relax, think, okay? You know you have a total of how many lessons? 6. But the first one is more expensive than the other. So you have one lesson. That's what? More expensive. And then you have how many lessons over here? 5. Now, here's what I think we should do. These 5 regular lessons, did they not all cost the same? Of course they did. So we're going to call these lessons X. Okay? So I know I have X plus X plus X plus X plus X. I have 5 lessons I'm going to add together. Now, my first lesson over here is 1.5 times a regular lesson. See, look, the first lesson is 1.5 times the cost of each additional lesson. So the additional lessons are X. I'm going to multiply that by what? 1.5. Let's go over that again. My regular lesson here is called what? X. I've got 5 of those regular lessons. However, the first lesson is not just X. Let's look at it like this, okay? Let's say, I'm just making this up. Let's say this lesson here costs $10, okay? Well, that means the first lesson would get multiplied by 1.5. And guess what? If you take 1.5 times 10, guess what you get? 15, which is right. So the first lesson costs 15, and all the others cost 10. So what you can do is you can take the regular lessons here, X, and multiply it by what? 1.5. So 1.5 X plus X plus X plus X plus X plus X. Now, these are all like terms. X term, X term, X term, X term, X term, X term. They're all X terms. We're going to simplify like we always do. There's 1X, a 1X, a 1X, a 1X, a 1X, okay? So, I have 1 plus 1 plus 1 plus 1 plus 1, that's 5, plus 1.5 is 6.5. So I have 6.5X equals 260. Now, I usually encourage you to get rid of fractions or decimals, but in this case, 6.5X is the same thing as what? 6.5X. And now with your calculator, just divide both sides by. I mean, I'm all for getting rid of fractions. I taught that to you for a reason. But let's not get carried away with it. Sometimes it is faster to go ahead and just leave the fraction or decimal there. So 260 divided by 6.5 is going to give you $40. Oh, excuse me, 40. Okay, got it? So, how much did each lesson cost? Well, X is 40. What does X stand for? Listen, guys, X does not stand for the cost of all 5 lessons. Absolutely not. X stands for the cost of one of these lessons. Look, I put it in there 5 times. 1, 2, 3, 4, 5. So X is the cost of one of your lessons here. So the regular lessons cost how much? 40. Now remember, this one over here is 1.5 times X. So if you take 1.5 times 40, you'll get 60. So the cost of the first lesson is 60. Now, if you want to check my work, that's fine. Take 40 times what? How many lessons were there? 5. Take 40 times 5 and you'll get 200. Then add 60 and you'll get 260, which is correct, okay? lesson is $60. All the others were $40. Alright, moving on to our almost our last problem. Two more left. Number 16. Some of your classmates ask you to type their English papers for 10 weeks. You really want to get these hang gliding lessons right here for $260, okay? So, how much should you charge for each page if you want to earn enough to pay for the hang gliding classes? But you also want to have $50 extra for spending money. You estimate you can type 20 pages a week. Now let's just really, again, like always, take a deep breath and think, okay, how in the world can I estimate my cost? Or not my cost, how in the world can I estimate how much to charge if I don't even know how much money I want to earn? So let's find that first. Your hang gliding lessons or classes cost how much? Remember, we just learned that back here, $260. But you also want to have $50 spending money for medical expenses after you crash, right? Just kidding. So you need 300. You want to have a total of $310. Okay. Now let's see what we got here. You're going to work for, this is your total you want to earn. I'm going to circle that. That's how much money you need right there. That is what you need. Now, you're going to work for 10 weeks. And you estimate you can type 20 pages a week. Now think about that. Let's make this easy. Every week, you're going to type how many pages? 20. You're going to do that for how many weeks? 10. So how many total pages are you going to be able to type? 200. Let's go over that again. You estimate you can type 20 pages a week. And you're going to do that for how many weeks? 10. So every week is 20 pages, 20 pages, 20 pages. That's 200 pages. Okay, sorry, students, I had to pause the video. Anyway, so 20 pages a week for 10 weeks. You're going to be able to type a total of how many pages? 200. Well, that's huge to know because now you can figure out how much to charge per page, right? Think about it, guys. Okay, you're going to take your charge per page times how many pages you can do, and that'll give you your total money, right? How much you charge per page times the pages. So you want your total money to be how much? 310. How many pages can you type? 200. And then how much should you charge? I'm going to put C for charge. Well, C times 200 is 200C. Divide both sides by 200. I'm getting a little sloppy here, but you can see what I'm doing. And your charge would be $1.55 per page. $1.55, 310 divided by 20 is 1.55. So if you think that's wrong, you're not sure, check and see. Take 155 times 200 pages, and you will get approximately $310. Okay, all right. Last problem. You are assigned a projector in science class. Excuse me, a project. You must use a hydrometer to measure the density of different liquids and then determine the specific gravity of the liquids. If you measure the density of ethanol to be 49 pounds per cubic feet, what is its specific gravity? Now, for those 2 or 3 students that have not passed out, let me explain something to you. I am not a science teacher. You guys know more about science than I do. I have no idea what a hydrometer is. I do not know how to measure density. Well, I do know how to measure density in some ways, but not with a hydrometer. I do not know what specific gravity of liquids is. Okay? I'm just telling you, I don't know this. But if you'll look in your book to the right of number 17, I should have taken a picture of this. I didn't. To the right, it says, are you ready? Oh, let's go back up here. What are we looking for? Let's stop right now. Even though we have no idea what these words mean, we can still write down what we're looking for. What is the specific gravity? Okay? So that's what we're looking for. We're looking for the specific gravity. That's what we're looking for. Got it? Okay. Now look in your books to the right of number 17, and you'll see it says the specific, underneath the picture, the specific gravity of liquid is, cool, they're giving me a formula gravity is a ratio of what? It's a ratio of density to the density of water. I'm just going to put H2O for water, alright? Trying to be cool here. There we go. Alright, now, so let's look at it again. Look in your books. I'm going to read again the specific gravity. Specific gravity is equals the ratio, so ratio of density to the density of water. Then in parentheses, it tells you what the density of water is. 62.4 pounds per cubic feet. So I can go ahead and erase density of water, and I can put a number in there. The density of water does not change. Well, I should be careful. There's probably different densities for salt water or the Tennessee River here in Chattanooga, because it's pretty disgusting and thick. I'm just kidding, but there's probably a little bit of a difference for salt water and stuff like that. But I'm going to go ahead and put what the book says. The book says 62.4 pounds per cubic feet. That's the density of water. I am so sad here. Look at this. You measure the density of ethanol to be, there it is. So the density of what we're dealing with is 49 pounds per cubic feet. And the density of water is this. We're done. Specific gravity equals 49 divided by 62.4, and you will get 0.79 approximately. And that's what squiggly lines mean. Instead of an equal sign, they put a squiggly line. 0.79. By the way, that's not congruent. Congruent in geometry looks like this. See the difference? Don't get those confused. Similar in geometry was this. Remember, that's similar. Approximately is an equal sign with a little bit of a wave to it like that, okay? Alright, so there, we're finished. Specific gravity is 0.79. That's the specific gravity of the ethanol that you're dealing with, okay? Now, I'm not sure what that means. I'm not a science teacher, but I can definitely solve the problem that they've given to me, okay? I hope this homework help video has been a help to you. If you have any questions at all, do not hesitate to